So we just learned from our note that in order to express the most general antiderivative of a function, we always have to add an arbitrary constant, which we usually call c. So let's remember that whenever we're asked for the most general antiderivatives, we must have c's in our answer. Here we're going to find the most general antiderivatives of f of t equals secant squared t. Well, since the derivative of the tangent of t is equal to secant squared t, which is equal to our f of t, that means that the most general antiderivative of little f is capital F, I'll call it capital F of t, equals the function whose derivative is secant squared. It is tangent of t plus the arbitrary constant c. Part B, let's find the most general antiderivative of the function h of x equals x squared minus 4x. Well, here we have the sum of two different terms. So let's first look at the fact that the derivative with respect to x of 1/3 times x cubed is equal to 3 times 1 cubed times x to the third power minus 1, which is, well, the 3's cancel and we get x to the second. And x to the second, that's a portion of our function h of x. It's not the whole thing, it's just the first term. So let's continue. And the derivative with respect to x of, let's say, negative 2x squared. That is 2 times negative 2 times x to the 2 minus 1, which is negative 4x. Well, heck, look at that. That also is a portion of our h of x. It's the second term. So let's put it together. The most general, and when we do the most general, don't forget the constant c. The most general antiderivative of little h of x is capital H of x equals the first term 1/3 x cubed minus the second term 4x plus our arbitrary constant c. And for our last example, let's consider the function g of x equals x to the n power, where n, the exponent, is greater than or equal to 0. It's not negative, it's greater than or equal to 0. Well, I do know this. I know that if I take the derivative of 1 over n plus 1 times x to the n plus 1, I will have to use the power rule, and I'll bring the n plus 1 down over n plus 1 times n plus 1 minus 1, which would give me x to the n, which is exactly g of x. So what I found here is the most general form of the antiderivative of little g of x is capital G of x equals 1 over n plus 1 times x to the n plus 1 plus c. And this formula is true for all exponents n greater than or equal to 0.